Alrighty, moving on to section 3.6. The start thinking part is this long dialogue between a teacher and a student, and the whole point is to get you to understand truly what congruent means. So it says Terry is trying to understand what congruent means. His teacher points to two orange desks in the front in the room and says, "Those two desks are congruent. The desks were arranged both facing forward and were the same model and the same manufacturer." Terry looks at a single desk that has been rotated to face the back of the room. So this one's not congruent to the other because it's facing the other way, right? No, that's not correct, he says. It's also congruent to the others. Okay, I think I understand, Harry says. He then points to two expo markers sitting on the bottom of the whiteboard. One marker is red and one is black. One is pointing to the right and one is pointing to the left. He says those markers aren't congruent, right? Because one's red and one's black. Frustrated, the teacher says, no, that's not correct. Those are indeed congruent to one another. Then Terry notices that all congruent figures were the same shape. So he had brought two apples to school that he recently picked, and they're the same exact shape, but just different size. He says, okay. He says to the teacher, are these two apples congruent because they're the same shape? Nope, the teacher says, those are not congruent. How about those? Terry asked, pointing to two sides of a heart shape that had been cut down the middle and formed a mirror image. Yeah, those are going to be congruent. Now, it says try to piece together all the information above to determine what it means to be congruent. What matters and what does not matter? What can be different about the objects and what cannot be different about the objects? So the first one, it sounds like when one of the desks was rotated backwards, that didn't matter. So it seems like the position does not matter. Like it could be at a different position. Then he has the markers and they're two different colors and they're still congruent. So it seems like the colors don't matter either. And then he talks about the two apples that are different sizes but the same shape, and those are not congruent. So it does seem like the size matters. And then lastly, when you have the heart shape and it's cut down the middle, those are going to be mirror images, and that seemed to not matter either. So the orientation did not matter. So putting all of that together, it says congruent seems to mean identical in form. Color, orientation, and position does not seem to affect whether it is congruent or not. Size or shape does matter. Okay. Now this next part here says the following shows a shape that has been drawn on the board. There's also a cutout that has been stuck to the board. You're asked if the following figures are congruent, aka identical in form. What is the easiest non-mathematical way to determine if the shapes are congruent? Well, we've done this a million times in the real world. You can just pick two things up and see if they sit on top of one another. So you could have just moved this cutout and slid it across the board and flipped it on top and seen if it landed on top of the other one. So you just shift it, and if I would shift the movable figure to see if it fits on top of the other. Now explain the movements that you would do. So number one, I would slide it over, and then it looks like I would have to rotate it a little bit, and then I would flip it. So if I have to keep it in contact with the board somehow, then that is what I would do. Now using the method above and your understanding of rigid motions, what rule could you say about how to determine if two figures are congruent? So in this case, it seemed like we translated, then we rotated, and then we reflected. So I believe what it is if you can use only rigid motions, translation, rotation, reflection, and get one figure on top of the other figure, then they must be congruent. Now our quick notes, congruent means same shape and size, color orientation, location doesn't matter. Now this is our first interaction with kind of the idea of a proof. We're trying to prove that two figures are congruent, and one of those is by using rigid motions. Two figures must be congruent if and only if there exists a set of rigid motions to get one figure onto the other figure. Okay, so if you're able to go over and do rotations, translations, and reflections and get one figure on top of the other, then they must be congruent. So an example here for the problem that we do in class is trying to figure out if these two figures are going to be congruent. Well, if you can do translations, reflections, and rotations, a bunch of some of them and none of the others, just as long as you use those things and can get one figure on top of the other, then they must be congruent. So one of the proofs would be a translation of -7/6 and then a reflection over x equals -3. That's going to fit the ABC perfectly on top of A prime, B prime, C prime, and therefore they are congruent. You could have also reflected over x equals 4, reflected first, and then gone over and done this translation of -7/6, and it would still fit perfectly on top. So those are two of the infinitely many ways to get ABC on top of A prime, B prime, C prime. Now, checking your understanding, you guys are supposed to be getting the ABC on top of DEF. And one of the ways could have been that you are going to go left by 9, up by 5, and then you're going to flip over the vertical line at -2. Now, another one could have been that you are going to reflect over x equals 2.5. The reason I did 2.5 is because it puts the figure perfectly underneath the other one, and then I could shift up by 5 units. These are two of the infinitely many possible proofs to get ABC on top of DEF. Now this next one right here is come up with a plan. When I'm looking at this, I can see there has to be a rotation in there somehow. Now a beautiful thing is you don't have to rotate around 0, 0. You can, and you could use your rules, but sometimes that gets a little tricky. You can rotate around whatever point you want. So in this case, I rotated around that point C, which is 7, 1. So I rotated by 90 degrees around 7, 1. After I did that, then I translated over by 5 to the left and down by 6. And then the two little acute angles where D is would be touching. And then I flipped over the vertical line at -1, and it ends up perfectly on top. So that would be one of the infinitely many possible ways to get ABC on top of DEF. Now this last one is going to be really tricky for me to be able to show because I can't like move a figure around. In class, I was able to actually have something stuck to the board and move it around. What you were supposed to do is try out each one of these and see if that makes ABC get on top of DEF. So you were supposed to first go over and flip over the vertical line at 6, then rotate by 180 degrees around 6, -8, and then translate left 9, up 11, and see if that ended up getting the figure on there, and it ends up doing it. So that would be one of the ones that work. The next one, if you tried to rotate 180 degrees around 6, -8, 6, -8 is point C. Once you do that, then you translate to the left by 9, up by 11, and then reflect over x equals -3. It ends up on top. And then the other one would be reflect over x equals 6. Then you would reflect over y equals the horizontal line at y equals -5, and then you would go left by 9 and up by 5. If you actually get this and maybe trace it out on a little piece of paper and move it around, you would see that one worked as well. So all of those worked. Those are all considered to be rigid motion proofs to show that one triangle is congruent to the other. Now, on 3.6, it says multiple choice. Two figures are congruent if and only if there exists a set of translations that map one figure to the other, there exists a set of transformations that map one to the other, there exists a set of rigid motions that map one to the other, or they exist a set of reflections. Well, you're allowed to use any rigid motion, so that would be it, the rigid motions. The next one, which of the following would guarantee that two figures are not congruent? Well, it is D. The figure is a different shape or size. All the rest, color, orientation, it has been rotated, would not change whether it's congruent or not. Next one, determine 3 transformations that show that, and it's supposed to be 2 transformations, you didn't need 3. I'll have to change that in before I print it out. There are infinitely many possibilities. I went and got my ABC, and I went right by 12 and up by 4, and that basically stuck them right next to one another. And then I flipped it over a horizontal line or a vertical line, x equals 7, and it landed on top. But it does need a reflection, and it does need to have that translation. The next one, determine 3 transformations that show that triangle ABC is congruent to triangle DEF. So this does look like it needs to have a rotation. So I rotated 90 degrees around 3, 1. I then flipped over the horizontal line at y equals 1. And then I went left 7 and down by 5, and it ended up perfectly on top of the other one. That is one of the infinitely many ways to get ABC on top of DEF. You should have a reflection rotation, most likely a translation, unless you're really clever about how you do your reflections. Okay. All right. List all that apply. If you try these out, you find that A and C will end up getting ABC on top of DEF, but B does not work. If you try to do B, it does not get ABC on top of DEF. So that would be the only one that would not be an actual proof. The rest of them, when you work through it, it does get ABC on top of DEF. And then lastly, it says Paul listed the composition of transformations. First translate, then rotate. Explain why this is definitely not a composition of transformations that maps one figure to the other. Well, I can see that there had to be a reflection because the orientation flipped. It's a mirror image. So there should be a reflection somewhere in there. All right, so the main thing that you guys need to know is that congruent means same shape or size, color orientation, location doesn't matter. Two figures must be congruent if and only if there exists a set of rigid motions, meaning translation, rotation, and or reflection that gets a figure on top of the other. That's your first introduction to the idea of a proof. Thanks for watching.